Behold the canyon. Grand Canyon. Awesome in wonder and beauty. How it engulfs the first-time visitor with its wealth of color and sheer majestic size. To stand at the rim of this truly awe-inspiring canyon with its many spires, temples, pinnacles, and gorges leaves most visitors breathless at the spectacle. For there exists nowhere else on the planet such a unique cross-section of the Earth's crust for all to see and explore. This grandest of canyons stretches some 277 miles through northern Arizona. The main portion of Grand Canyon attains a depth of more than a mile and ranges from 4 to 18 miles in width. The North Rim, somewhat higher than the South Rim, reaches an altitude of 8,500 feet, while the Colorado River cascades along at about 2,400 feet. The South Rim is host to more than 4 million visitors each year. They come from around the world to Grand Canyon to see the magnitude of such a landscape. Standing at the rim of Grand Canyon compels the visitor to consider the inside story of the ground beneath their feet. The Anasazi Indians lived in the canyon before the Spanish arrived in 1540. Garcia Lopez de Cardenas was the first European to see Grand Canyon, and only a handful of trappers visited the canyon until Major John Wesley Powell, the first geologist to explore Grand Canyon, led an expedition of 9 men down the Colorado River in 1869. Powell began what geologists will never finish: the complete deciphering of the rocks of Grand Canyon. Observers of Grand Canyon begin asking questions. What was the process that laid down the sedimentary strata? How were the fossil remains of plants and animals encased in these rocks? Why do these strata compose such a widespread and high plateau land in the southwestern United States? And how was it eroded? What are the facts? Because no human was present to observe and record most past geologic events, we can never be absolutely certain of our interpretation. However, our interpretation process of Grand Canyon is not without foundation. Rock strata and fossils are used by geologists to build their interpretations of history. As in other fields of study, data of interest to the geologist are evaluated by placing them into some type of interpretive framework. This framework consists of a series of premises or postulates from which conclusions concerning the meaning of the raw data are derived using logic. These premises that form the interpretive framework are held to a large degree in faith by the individual geologist. At this point, we come to the crossroads of geologic facts with opinion and belief. 2 geologists stand at the rim of Grand Canyon. One is an evolutionist, and the other is a creationist. The evolutionist sees the rock strata and fossils of Grand Canyon and processes these data through a uniformitarian framework of interpretation. The evolutionist concludes that rock strata and fossils of Grand Canyon formed during millions of years as calm and placid oceans advanced and retreated slowly over North America. Strata and fossils are supposed to be natural products of the slow passage of geologic ages. The creationist sees the same rock strata and fossils of Grand Canyon as the evolutionist. However, the creationist processes these data through a catastrophist framework of interpretation. The creationist concludes that rock strata and fossils of Grand Canyon were caused primarily by a global flood. Some strata may have been accumulated during many hundreds of years before the catastrophe, and some strata may have formed after the catastrophe. But creationists generally suppose that most of Grand Canyon strata, exposed so obviously today, were deposited rapidly during a single advancing and retreating flood. We know why both evolutionist and creationist explanations of Grand Canyon strata and fossils exist, Each explanation is really an historical interpretation of Grand Canyon derived through the presuppositions or framework of the interpreter. The controversy continues because no human observer was present at Grand Canyon to see and verify what actually happened. Let's look at 7 evidences that lead us to consider the history of the Earth as seen in Grand Canyon strata. The first evidence for us to consider is ocean over the continent.
Here we are at the south rim of the Grand Canyon at about 7,000 feet elevation, and the rocks that appear here at the south rim are limestones, and as we study these limestones, we see some very unusual features, some very interesting features. We see first off that there are fossils in here. We see sponges. Now, what sort of an environment do sponges grow in? Well, today sponges grow, of course, at the bottom of the ocean, and the same with the brachiopods that we find here. And coral, these are ocean bottom creatures. Evidently, these rocks were accumulated as muds at the bottom of the ocean. But here we are at 7,000 feet elevation, and could this be an ocean bottom? Evidently, the ocean covered the continent sometime in the past.
We're at Kanab Canyon, a major side canyon along the north rim of Grand Canyon. This enormous canyon, one of the largest side canyons on the north rim of Grand Canyon, exposes the Hermit Formation or Hermit Shale in a marvelous way. Behind me we can see this reddish clay-rich formation called the Hermit Shale, and in it it has fern fossils, fossils of terrestrial plants like ferns, and it has marine fossils, fossils of ocean-dwelling organisms. How was the shale of the Hermit Formation deposited? As we think about this, we can look at this extensive layer of clay, rich reddish clay formation, and we wonder, was it deposited in a river delta or on a river floodplain? We don't see the channels in the shale formation that would suggest a river floodplain. And as we look at the broad, extensive nature of the Hermit Formation, it doesn't have the wedge shape or triangular shape of a river delta. Instead, it's a broad formation that can be seen through 200 miles of Grand Canyon. Many geologists believe that the Hermit Formation and some of the other strata associated with it were deposited underwater, under marine water, in a marine flood condition. This model for the origin of the shale-rich Hermit Formation seems to explain what we see in the Grand Canyon. As we look at the Hermit Formation and the great mud deposit that formed this shale strata, we think almost immediately of a catastrophe on the order of Noah's flood.
We've seen evidence that the ocean was over the continent. Now let's explore evidence for rapid burial.
Here we are in the Redwall Cavern, in the midst of the Redwall limestone inside the Grand Canyon. The Redwall limestone is one of the most fossiliferous units in the entire Grand Canyon. And all the fossils found in the Redwall are in fact marine organisms. This seems to indicate that the Redwall limestone was deposited in a marine environment. That means that whatever deposited this particular formation that's around me, above me, below me, beside me, and so on, it was in the midst of an ocean. Yet now, we're thousands of feet above sea level. So it would seem as if at some point in the past, there was an ocean over this location, over this entire continent, if it was this high. More particularly, the fossils that are found here, such as the boulder in which I'm sitting, has some crinoids and some bryozoans in it. These are very fragile creatures in the sense that once they die, their parts quickly disseminate over the surface of the sediment on the seafloor. The fossils, in contrast, in the boulder beneath me, are in fact still intact. The crinoid still with its individual columnals fitted together into the column that supported the head of the organism. And the bryozoans still together in the fan-shaped structure in which all the thousands of little organisms lived. The fact that those bodies are still together seems to indicate that whatever deposited them, buried them rather rapidly while they were still alive. Before they began to disarticulate after death, they were buried in this fashion. So this would seem to indicate that not only was the ocean here, but also that the ocean that deposited these organisms did so very rapidly, took living organisms, ripped them off of their living position, and buried them in another location fast enough so that the decomposition of the body didn't destroy the creature itself. So what we have is evidence of a fast-flowing ocean over the continent, thousands of feet higher than present sea level. We might ask what something like that might be, and we believe that it could only be explained by something like a worldwide flood, as the Bible records in the day of Noah. Here we are in the Redwall limestone, about halfway down vertically in the Grand Canyon. We are in a portion of the limestone about 1/3 up from the base. We're in a side canyon off of the Colorado River by the name of Nautiloid Canyon. And here in the canyon below me, we have some interesting fossils preserved in the rock. They're called nautiloids. Nautiloids are kind of cigar-shaped shells of organisms that kind of similar to squids, like a squid with a shell. Because of the shape of the nautiloids, they're the sort of organisms that can get oriented by currents, and it's because of that that we're interested in the ones that are found here beneath us. The traditional interpretation of the Redwall limestone is that it's accumulated by particles of organic material and particles of shells falling down through the water column over thousands and millions of years. As such, you would expect that if nautiloids lived in this area for the duration of the time, that you should find nautiloids above us and below us and on every level. And that doesn't seem to be the case. We find lots of nautiloids in this particular level here, but very few to none are found in other layers above and below. It appears as if the nautiloids that are found here were buried at only one moment in time. Furthermore, if in fact the Redwall was formed by the gradual deposition of material over a long period of time in a calm, placid sea, you would expect that there would be no currents to orient those nautiloids as they fell down to the bottom. So you'd expect them to be randomly distributed in orientation, but that's not what you find here. What you find is that they seem to be oriented in a more or less north-south direction as we see them here. And that seems to indicate that not only did they die quickly at one moment in time, but also that they were oriented by something, probably currents, in a particular direction. This seems to argue against that calm, uniform deposition of material in the Redwall, but rather argues that there was some event, maybe that killed these organisms in the water column at a single moment in time, and then they fell down to the bottom and were buried very rapidly in some event occurring in a very short period of time. So rather than a very gradual deposition of material over long periods of time, we have evidence here of a rapid kill event sometime in the Earth's past. One interesting feature of the Coconino sandstone, which is actually above me here in the Grand Canyon, and the Esplanade sandstone, on which I'm sitting on a few blocks of that particular sandstone, is that they contain some fossil footprints. Footprints of organisms that appear to be four-footed organisms of the reptile or amphibian type. Here you can see a sequence of right-left footprints in a whole trackway with toes and toe marks and claw marks, which indicate that it's an organism that scampered across this sand sometime in the past. One interesting question is, what were the conditions under which this organism traipsed across this surface so long ago? As we look at the footprints, we find that there are a few clues. For example, we find that the animal's toes are not lined up with the direction that the pathway takes. That actually the toes are oriented at an angle with respect to the trackway, as if the animal was turning into a current of some sort. In order to go in one direction, he had to turn into the current, trying to push him in another direction. What kind of current was that? Well, based upon the size and structure of the amphibians and reptiles that would likely have made these kind of tracks, it appears as if it's probably water. They sit so low to the ground that wind would probably not have that kind of an effect on them. So that appears to indicate that it's a strong water current that is pushing these organisms off of their main course. We have a couple of other indications that these trackways were made underwater. One is that the creatures are actually running along in the sand, and then they disappear off the surface of the dune that they're walking on and appear on the next dune down the way. It's as if they either flew through the air and landed on the next dune, or they left the dune floating in the current and landed on the next. The second hypothesis seems more reasonable, so it appears once again that the organisms are running in water and get transported to the next dune. A third piece of evidence that indicates that these organisms were underwater at the time is that their trackways are most similar to the kind of trackways that are found when we put reptiles and amphibians underwater and have them run on the bottom, rather than those that run on wet sand or those that run on dry sand. So here the evidence seems very strong that these footprints in both the Coconino sandstone above me and the Esplanade sandstone that I'm sitting upon are actually running against strong water currents. And then in fact, water currents of a significant magnitude are the source of these sands. That's what brought these sands into being.
We've looked at both fossils and trackways of organisms which show rapid burial. Next, let's consider the widespread occurrence of strata.
Here in Grand Canyon, we see one of the most extraordinary displays of rock strata layering anywhere in the earth. Grand Canyon provides the inside story to the ground beneath our feet. And as we look at these rock strata layers, we're amazed at their horizontal continuity. Individual strata layers can be followed through the canyon 200 miles, thin strata layers. We're on this one sandstone layer, the Upper Supai Group Formation, and this sandstone layer can be seen through the length of the canyon along the Colorado River, a distance of about 200 miles. Under what condition did this sandstone layer accumulate? Was it a river floodplain that deposited this sand along an ancient river? Or was this sandstone deposited in a delta where a river went into the ocean? Well, we look at this sandstone layer, we do not see river channel features, and we don't see the triangular shape of a river delta where it might have gone into the ocean. Instead, the sandstone layer forms an enormous blanket over northern Arizona. As we think about the extraordinary extent of the different sandstone layers in Grand Canyon, immediately comes to our mind a flood of continental dimension. Could there have been a great oceanic flood over northern Arizona that was rapidly depositing sand, distributing sand from enormous areas? Long distance of transport of sand over broad areas, evidence of ocean being over the continent. These things immediately bring to mind a flood of the scale of Noah's flood. Something like that becomes obvious as we're thinking about the widespread layering here in Grand Canyon.
Let's consider boundaries between strata and the time that may be involved.
Geologists are very interested in the boundaries between different formations in the Grand Canyon. We're here on the Colorado River at the boundary between the Toroweap Formation, which is underneath me, and on top of me here is the Kaibab Formation. These two formations are limestone, and the boundary between the two rock strata layers or formations has been the point of intense controversy. Some geologists have believed that the two formations were deposited by two different oceans. There was first an ocean that deposited the Torreweep Formation, and then this ocean receded and the land surface was exposed, perhaps as the continent was uplifted. Then the ocean advanced over the continent again and deposited the limestone that we see above us, the Kaibab Formation. The two formations, and this boundary right here is the site where some evolutionists have said that there are millions of years of missing rock strata. There had been suggested there were two different oceans that deposited these layers. The Torreweep Formation deposited by the Torreweep Ocean and the Kaibab Formation by the Kaibab Ocean. Geologists are disputing the two different ocean theory for the accumulation of these two limestone formations. This surface I'm sitting on right here is not a soil zone or a weathered surface or a channeled horizon where millions of years of weathering and erosion would have occurred. As we look at this, we see the two formations stacked on top of one another without obvious evidence of missing millions of years. So geologists are suggesting short time intervals between formations, not millions of years between formations. This suggests that a flood model may be the best way to explain these two formations. Maybe just one ocean or one flood deposited both of these formations. Sandstone and shale strata of the Grand Canyon have fascinated geologists for more than 120 years. We're here at the boundary between two adjacent strata layers. Underneath me is the Supai group sandstones. Here a thick sandstone layer forming the upper part of the Supai group strata. And above me here, alongside of me, is the Hermit Formation, sandstone, siltstone, and shale. The two formations contact right here along this boundary. This boundary has been fascinating to geologists because they've suggested this is a surface of erosion. The water which deposited the sand at this one location is thought to have left the area, and the whole surface of the Supai group was eroded over a long period of time, some have suggested. Then a water, like a stream or something, brought in more mud and silt particles and some sand and deposited the Hermit Formation. The two formations sit on top of one another with this erosion surface in between, as some geologists have suggested. But if you look here in detail at the contact between the two formations, it is not at all obvious that there's missing millions of years between the strata layers. There seems to be a gradational change from the sandstone below to the siltstone and the shale rocks above. The two formations seem to interfinger with one another, forming this very unique and extraordinary contact. Many geologists now are doubting that there are millions of years missing along this strata layer contact. Again, this is another example of short time periods between strata layers.
Geologists would maintain that probably the most important, most significant geologic event in the entire Grand Canyon is associated with what they call the Great Unconformity. And here I am at the Great Unconformity in the canyon. It corresponds to this line between the darker sediments below and the lighter sediments above. The Docks Formation is what we call this formation below. The Tapete Sandstone, what we call the formation above. It's at this particular point that we have a significant amount of missing time according to conventional geologists. The Docks Formation dates from over or greater than 1 billion years before present. The Tapete Sandstone, in contrast, dates from about 500 million years before present. So there appears to be, if that is right, 500 million years of time missing between the deposition of the docks and the deposition of the Tapete Sandstone. Now, if that particular hypothesis is true, then we would expect that over that 500 million years of exposure, this formation below, the Docks Formation, should show evidence of what we call chemical erosion. Water percolating down through these sediments with acid should transform these sediments chemically. We should see the development perhaps of soil horizons, or at least some modification on a chemical level. But that doesn't seem to be what we see here. We seem to see a rather uniform distribution of chemicals throughout this particular unit. No real change as we come up to the boundary, an abrupt change right at the boundary. This seems to argue against the existence of chemical erosion, but just for the existence of physical erosion to plane off the surface. If there was a tremendous amount of time, like 500 million years, between the docks formation and the Tapete sandstone, you would expect that erosion of the docks would produce a sediment that is what we in geology would call mature. That means the mineral grains might be reduced down to things like quartz, but things like feldspar would have been chemically eroded into clays, and they wouldn't be found at all. However, what we see in this unit, in contrast to that, are a number of grains of both quartz and feldspar. This would seem to indicate that not a tremendous amount of time has elapsed in the deposition of this unit. We've ripped the material off of the underlying unit and deposited it rather rapidly before chemical erosion could transform it. So rather than evidence of a significant amount of time at this particular boundary, what we see is the absence of chemical erosion both above and below, such that we conclude that there isn't a lot of evidence of chemical erosion here and thus of time. We do have evidence of erosion, erosional surface here, but it's entirely physical erosion, not chemical erosion. What we believe is that the erosion event here corresponds to the erosion event at the beginning of the flood. Significant amount of physical erosion, but not enough time elapsing in the process to allow for chemical erosion of the sediments below and the sediments above.
Let's consider faulting and folding of Grand Canyon rocks and the evidence of massive tectonic upheaval.
In this particular canyon, low area in the Grand Canyon, we find rocks we'd normally find in the Grand Canyon all about us, but what we're standing on, the rocks immediately around us, are a different type of rock, a rock that is found only in a few places in the canyon. That appears to be because of some unique and pretty astonishing geology that happened at some time in the past. There's a set of faults here in front of us, a set of faults behind us that have apparently brought this material down thousands of feet from up above. And then while it was falling down, apparently large boulders of material, hundreds of meters in diameter, rolled off the cliffs from up above and collected down here to create the formation which is up and behind me, the 60-mile formation at the top of the Nankoweap Butte. Then, while this material was still low relative to the material above it, there was a large erosion event which shaved everything off, something we call in the Grand Canyon the Great Unconformity. That particular erosion event then was the beginning of the deposition of the normal rocks of the Grand Canyon. The way we interpret this incredible tectonic event is that it all occurred about the same time at the very beginning of the flood. That maybe the breakup of the fountains of the Great Deep initiated some large earthquake activity that dropped this material down and then began the cascading and deposition of material, and then a great erosion event at the beginning of the flood shaved everything off, saving the rocks in this area from being eroded because they had formerly been dropped down. And then the flood began to make the normal deposition of sediments we find elsewhere in the Grand Canyon. The 60-mile formation is probably one of the most spectacular units in the entire Grand Canyon, at least from my point of view. What we have here is a number of evidences that the unit was deposited very rapidly. You see a number of them here. We have alternating layers of cross-bedded sandstone and breccia units. The cross-bedded sandstone units show evidence of cross-bedding, very rapid deposition, maybe even anti-dune formation, which would be very rapid deposition of those particular units. Alternating with them, you find some breccia units. Breccia is referring to a rock made of angular fragments of other rocks. Normally in the tumbling of rock fragments in water, you round off the pointed edges. These are extremely angular, as you can see, and what this would indicate is that not a lot of time or distance has transpired since these rocks have been ripped out of their original formation and deposited in this particular unit. In fact, in this particular layer, you not only see breccia, those angular fragments that indicate very close deposition to the point where it came from, but also these particular breccia clasts are imbricated. It means they're all lined up, pointing in one direction. They're not horizontal, they're lined up, stacked on top of one another, and they sort of point downstream of a current flow. To imbricate breccia clasts like this requires very rapid motion of water, rather catastrophic conditions. In addition, we find boulders in this particular unit. We have boulders anywhere from a foot in diameter to, in fact, hundreds of meters in diameter. The combination of these factors, the cross-bedded sandstone, the breccia units, the imbricated breccia units, and the boulders and the huge boulders that are found in this unit testify to an enormous tectonic cataclysm that occurred sometime in the past.
We can see abundant evidence for the tectonic upheaval that marks the onset of the flood period. For example, behind me here we see the Hakkatai Shale and the Shinomo Quartzite, two of the pre-flood strata that we find here in the inner part of the canyon. These strata have been tilted, obviously as a result of the upheavals that mark the flood period. As well as tilted strata, we see faulting in the canyon, particularly in the Vishnu schist and up into these pre-flood strata. For example, we see the Hurricane Fault, where there is a displacement of over 1,000 feet, where blocks of these strata have been pushed up. Again, tectonic evidence for the onset of the flood. There is also evidence of rapid erosion, where these pre-flood strata have been eroded and carried along by catastrophic water transport. For example, boulders of Shinomo Quartzite that have been plucked up. These boulders measure feet in diameter and have been included in the sand of the Tapete Sandstone. And then on Nankoeat Butte, we see the 60 Mile Formation at the top of this sequence of pre-flood strata. In that formation, we see large boulders and other evidence of catastrophic upheaval also. All of this evidence put together shows us that there was massive tectonic upheaval at the onset of the flood.
Here in the eastern Grand Canyon, we see the geologic structure that's responsible for Grand Canyon being here. We see the strata over here on the east. They're low strata, and as they come to the west, they are warped and tipped upward about 3,000 feet. And on the west, the strata rise and then flatten out to form the upwarped Colorado Plateau, or what's called the Kaibab Plateau here. This whole area is a zone of flexing of strata. About 3,000 feet of vertical upheaval has occurred here along a north-south trending line that extends for hundreds of miles through the Colorado Plateau. Imagine the faulting that must have occurred at depth to cause the strata to be shifted to form this plateau. The Grand Canyon is ultimately a monument to upheaval and tectonic forces that boggle the mind. Imagine the size and the scale and the power of the energy involved with uplifting a plateau, thousands of square miles in area, over 1.5 miles above sea level. It's incredible to think about.
Upheaval of the earth leads naturally to erosion. Let's consider evidence for rapid erosion.
This canyon is magnificent. But you know, even if this canyon wasn't here, the plateau that we're sitting on has an interesting story of its own to tell. Look around the rim of this canyon. See how flat it is? Everywhere it's the same level, both geologically and structurally. Okay. We are sitting here on the Kaibab limestone, and this limestone rims the canyon all the way around. And look how flat it is. Imagine if this canyon was filled in. If it wasn't here, this was one great vast plain before this canyon was cut. Now, what do we think of when we usually think of a vast plain, a flat surface? We usually think of a depositional environment, a depositional surface, something like the bottom of a lake bed or the bottom of the ocean. But yet this is an erosional surface. We know that because elsewhere we see other units on top of this that have been stripped away. For example, at Red Butte, we have over 1,000 feet of rock layers that are on top of this Kaibab limestone. Where did those go to? How were they stripped off, leaving such a flat, featureless plain? We know that rivers, when they erode channels, and they dissect the land, creating a topographic surface with a lot of relief, particularly if it's elevated at a level of thousands of feet, as this is. The only way we can get this kind of flat erosion is if we have some sheet-like, what we call sheet erosion, which happens when you have a flood of water, huge amounts of water sweeping over a surface in a short enough amount of time that it can't form channels. It just simply sweeps away everything, leaving it clean and smooth. And that's what I believe happened here. When I think of the incredible amount of sheet-like erosion that would be necessary to produce a plain of this size, it brings to mind a catastrophic flooding event where incredible amounts of water were running off of the continent. This could have been even of the magnitude of Noah's flood.
Grand Canyon is recognized as the world's greatest erosional wonder. The Grand Canyon is 277 miles long, 4 to 18 miles wide, and a mile deep. It's been estimated that more than 900 cubic miles of material has been eroded to form just the erosional profile of Grand Canyon. How did that erosion occur? It's one of the most controversial aspects in all of geology. The satellite photo shows the magnitude of this river location problem and the erosion of Grand Canyon. From outer space, you can see the upwarp plateau in northern Arizona. Conifer forest covers the north rim of Grand Canyon over 8,000 feet above sea level. And the plateau land to the south of Grand Canyon, the south rim, is about 7,000 feet above sea level. How is it that Grand Canyon is positioned through this upwarp plateau? The drainage basin to the east and to the north of Grand Canyon is 5,000 feet above sea level. We see this amazing upwarp and the river positioned through the upwarp. How is it that that has occurred? It's almost the river that runs over a hill. How did that river get located there? There are three theories for the erosion of Grand Canyon. The first theory is the theory of the ancestral river. There was a great, very old river that flowed through northern Arizona as it was a low plain. The plateau was slowly uplifted as the down-cutting of the Colorado River occurred, and over tens of millions of years, the result was the Colorado River drainage basin. Most people, most geologists are skeptical of that theory. That's the elegant and simple theory, but there's all kinds of evidence against the ancestral river, a very old river flowing through northern Arizona. We haven't found the river deposits from that ancient river. The second theory is the theory of a runaway gully. Can you imagine the ancestral Colorado River not flowing through northern Arizona, but flowing off into New Mexico somewhere? And this gigantic gully began to erode through the upwarp plateau. From Nevada eastward through the upwarp plateau, this gigantic gully intercepted the ancestral Colorado River and diverted it through this gully. It would be a unique and precocious gully that would cause Grand Canyon to be positioned where it is now. It would be the world's most amazing natural accident. It's an incredible improbability. Some geologists are thinking that way. One of the most interesting theories is the third theory, the theory of a breached dam. There's evidence of a great lake which existed to the east of Grand Canyon behind this gigantic upwarped area Could the upwarp have blocked the drainage basin of the Colorado River and a giant lake or series of lakes formed behind the dam, the natural dam? Many geologists are suspecting that some kind of breaching event occurred. The dam would be overtopped or failed somehow, and rapid drainage of water occurred through the upwarp plateau. Could Grand Canyon be a gigantic spillway formed from catastrophic drainage of lakes? Some geologists are starting to think that way. There are new ways of thinking about the erosion of Grand Canyon, and these are consistent, I believe, with the idea that Noah's flood and the post-flood period was responsible for the formation of the Colorado River drainage basin.
The Colorado River itself only occupies a narrow valley today, an inner gorge within the broad Grand Canyon. Indeed, the canyon is enormously wide in places, and yet the Colorado River does not seem today to have the power capable of having carved out the canyon. We see that also in the side canyons, where the boulders that are there and the down cutting that must have occurred indicates that there was much more water flowing both in the side canyons and in the main canyon itself in the past. This all points to rapid erosion. The time when the Kaibab upwarp was pushed up to trap waters in a huge lake that burst through a lot of water in a little bit of time. The Colorado River itself is only a remnant of the massive amount of water that must have catastrophically carved out the canyon.
The May 18, 1980 eruption of Mount St. Helens in Washington state provided important examples of rapid canyon erosion. The whole landscape north of Mount St. Helens was radically transformed to make the new drainage basin of the Toutle River. The landscape north of the volcano was blocked by landslide debris on May 18, 1980. It was breached by mud flows on March 19, 1982. The new drainage basin includes a little Grand Canyon, 1/40th scale of the real Grand Canyon. If we had not seen the rapid erosion of canyons at Mount St. Helens, we might suppose hundreds of thousands of years of slow stream erosion formed the assortment of canyons that we see at the volcano. Even solid rock was eroded to a depth of 100 feet or more after the recent eruptions. Mount St. Helens stands as a monument to catastrophic erosion and helps us understand rapid erosion of Grand Canyon.
What about those radioactive dating methods? Do these provide evidence for millions or even billions of years in Grand Canyon?
The Cardenas basalt is a series of lava flows occurring deep within the eastern Grand Canyon. Ancient volcanoes accumulated lava flows with a thickness of up to 1,000 feet. This geologic model of Grand Canyon shows how the Cardenas basalt is deeply buried beneath thousands of feet of strata. These lava flows of Grand Canyon are assumed by many geologists to have a great age, an age of over 1 billion years. Geologists have attempted to date the Cardenas basalt using radioactive isotopes. A radioactive parent element or isotope decays to a non-radioactive daughter isotope or element. The proportion of the radioactive parent to non-radioactive daughter can be used to estimate the age of the Cardenas basalt. An age of 1.7 billion years was obtained using the samarium-neodymium isochron method. An age of 1.1 billion years was obtained by the rubidium-strontium isochron method, and an age of 0.7 billion years was obtained using the potassium-argon isochron method. The three different radioactive isotope dating methods give three different ages for the Cardenas basalt. These discordant ages cause us to ask questions. What is the true age of the Cardenas basalt? Is it A, 1.7 billion years, B, 1.1 billion years, C, 0.7 billion years, or D, none of the above. Some geologists respond none of the above and wonder if anyone has successfully dated a Grand Canyon rock using radioactive isotope methods. We're at a place called Vulcan's Throne. Vulcan's Throne is this cinder cone volcano that is behind me here. Very symmetrical profile mound of volcanic cinders that forms that kind of conical structure called a cinder cone. And Vulcan's Throne is not just an ordinary volcano. We might think of it as one of the world's most extraordinary volcanoes because Vulcan's Throne sits on the north rim of Grand Canyon, and it's the source of a series of lava flows that flowed into Grand Canyon. Can you imagine what it must have been like when the volcanoes erupted on the north rim? The lava spilling 3,000 feet down into Grand Canyon. It was an extraordinary sight, no doubt. We actually see the lava flows down at the river. They blocked the river and made a giant lake in the Grand Canyon. Vulcan's Throne is not the only volcano on the north rim of Grand Canyon. There is a whole province of volcanoes that occur along a fault line that runs north-south across the Grand Canyon. And on the north rim of Grand Canyon, we have a whole line of volcanoes. These volcanoes are extraordinary and have been the source of study, of chemical and isotopic studies. And these volcanoes tell an interesting story, and geologists are just beginning to understand that story. A series of lava flows from the north rim of Grand Canyon, from the Urinkaret Plateau, were dated using the rubidium-strontium isochron method. That's the same method that was used to date the Cardenas basalt, that deeply buried basalt layer in the Grand Canyon at 1.1 billion years. The graph that we see here shows the radioactive parent versus the non-radioactive daughter. And we see this sloping line suggesting that the recent lava flows on the north rim of Grand Canyon are 1.2 billion years old. This age, of course, is preposterous. Those lava flows cannot be 1.2 billion years old. They're just thousands of years old. Something appears to be wrong with those radioactive isotope dating methods which assign great ages of billions of years to Grand Canyon rocks.
5 geologists have explained to us 7 evidences that relate to the origin of Grand Canyon. These evidences, however, do not tell a conclusive story because no human was here at Grand Canyon to witness these events. We have told this story consistent with the framework of creation and the flood, as described in Scripture.
When I look at this canyon, I don't see just a testimony to the forces of nature sculpting a landscape. I see an incredible testimony to the greatness of our God, not only to the forces at work in creation and in the flood, but to the whole counsel of Scripture. I see here evidence of the consequences of man's rebellion against God. This great chasm, these rocks filled with testimony of what the fall brought to us, of death. You know, our God bridged a much greater chasm than this when He came and delivered us from our own bondage to sin, from the consequences of sin, which is death. I'm reminded of what the psalmist said. O Lord, our Lord, how majestic is your name in all the earth. Who has displayed thy splendor above the heavens? I thank the Lord for this canyon. I believe this canyon is an incredible testimony, not only to His power, to His creative forces, to His judgment in the flood, but also to His grace.
As a Christian and a geologist, the canyon challenges me personally. The awe-inspiring sight of the spread of strata, the thickness of strata, the fact that the strata and all the upheavals show the whole sweep of Earth history as recorded in the Scriptures. I am reminded that the Scriptures indicate that God has left in the earth testimony of his acts, both in creation and the flood, and we see it here in the canyon. And that challenges me, but it also reminds me of the challenge that it is to people everywhere, in that God has said that just as he has judged the world the first time by water at the time of the flood, and we see abundant evidence of that here in the canyon, then the next time he is going to judge by fire. And personally, that challenges me to be ready to meet my Creator, but it also challenges me to be able to share this information with others so that everyone also can have the same challenge and recognize their need to be reconciled with their Creator, the one who made this world and judged this world at the time of the flood, as we see here in the canyon.
The most impressive aspect of the Grand Canyon for me is its incredible beauty. In the midst of the event that brought it about, which I believe was Noah's flood, God, even in judging human beings, left evidence of that which left incredible beauty. The holiness of God brought about the necessity of that judgment and the events that brought the canyon into being, and yet in spite of that, in the midst of the judgment that he was bringing upon the earth, even in that, God shows himself beautiful. And I've been reminded many times that in the midst of tribulation, personal tribulation, or whatever, God uses that to show himself beautiful. He makes all things beautiful, even those times that we find difficult and discouraging. And that's what I see in the Grand Canyon. Most incredible judgment God ever laid out on earth, yet the evidence of it is so very beautiful.
The more I study the evidence here, the rocks and the fossils and the erosion pattern and all these things, the more I come to the conclusion that a flood must have done it. This evidence is just what it should be if a flood like the flood in Scripture really happened. It would have done these sorts of things. But then when we think about that, we've got to recognize that that flood in Scripture was really a judgment of sin. It was a punishment of that sinful world in the days of Noah. God hates sin. God always judges sin, and this is the grim reminder of the hatred that he has for sin and the attitude and what he does. He punishes sin. But it's also interesting to me to realize that this canyon, which is just so beautiful, I love it here, and it's just so beautiful, but it's really the destroyed remnant of the world before the flood. Can you imagine how beautiful that pre-flood world must have been so that the destruction of it would look like this?
3,000 years ago, the children of Israel were crossing into the Promised Land. They were on the east side of the Jordan River, and the priests carried the Ark of the Covenant into the river, and a normally free-flowing river dried up, and 1 million people of Israel crossed into the Promised Land. The great miracle that occurred there was emphasized because the tribes of Israel picked up stones, and they piled the stones on the west bank of the Jordan River. And Joshua said to the children of Israel, when you and your children see these stones and ask, what mean these stones? Ye shall say to them, these stones are a memorial to the great thing that God has done. And as we look at the Grand Canyon, we see something of the marvelous testimony of God in setting up these stones, a gigantic memorial to creation and the flood. As I look at the Grand Canyon, I see God's handiwork and God's judgment, and I see ultimately his provision and redemption. Those are the things that I see here in Grand Canyon.
Further information on the topics of this video is contained in the book Grand Canyon, Monument to Catastrophe, edited by Stephen A. Austin. This and other books and videos on geology are available from the Institute for Creation Research. The Institute for Creation Research also offers yearly tours to Grand Canyon. For further information on publications, tours, and college credits, call or write the Institute for Creation Research.